Hi everybody, this is Mr. Folly, and welcome to a podcast. Hopefully you just enjoyed our wonderful test we just took on nomenclature, and we're now looking forward to actually using naming to figure out the parts of a reaction, states of matter and symbols, symbols in reaction, and then basics of balancing. Uh-oh, lunch started. So let's go ahead and hop to it. Aqueous silver nitrate reacts with sodium chloride solution to form solid silver chloride and aqueous sodium nitrate. Arg, so many words, so long, arg. We're going to figure out how to actually do this. I assume you've seen some of these reactions before. Remember, reactions start with a reactant, and those reactants turn into products. So aqueous silver nitrate, I see silver nitrate, and I can name silver nitrate. Silver is Ag. Silver, of course, is +1. Nitrate is NO3 negative. And if it's aqueous, the way I would indicate this is aqueous is put a little AQ. And we'll talk about aqueous a little bit later. Reacts with sodium chloride solution. Sodium, Na. Chloride is one element, Cl. Sodium is +1 from the periodic table. Chloride is -1 from the periodic table, so it's NaCl. Solution also means aqueous. To form, that means makes. This arrow right here, which I will call yields, and so will you. To form solid silver chloride. Ag, silver, chloride, Cl. Silver's +1, periodic table. Chloride's -1, periodic table. Solid. Little parentheses there. And aqueous sodium nitrate. And plus sodium, Na, +1, nitrate, NO3, -1, charges cancel. Aqueous means aqueous. So if I were to ask you what the reactants were, you would say these are my reactants. If I asked you what the products were, you would say that these are my products. And hopefully you followed very well what the different names of the different stuff was. So same things we did before. So now we've got to get used to some of the symbols we're going to use. Symbol for solid, there's two different ones. One is a little s, of course. The other one is a little down arrow, like solids that sink. Wordy would just be solid or precipitate. Solid or precipitate. Precipitates are often abbreviated PPT, which is how I will abbreviate it from here on out. Liquid. I use a cursive L so it doesn't look like just a 1. So, wordy, liquid. Gas. A gas can either be a little g, yo dog, or it can be an up arrow. The up arrow would also be small and in parentheses. Bubbles, gas, etc. Something that indicates that state of matter. Aqueous is a little AQ, and aqueous is different from liquid state, and we'll talk about that here in a little bit. I think that's the next. So, you know what, I don't see that in a little preview here. So aqueous actually, well, I guess the wordy part will tell me this, would be dissolved in water, or the word solution, or aqueous. Catalyst, the symbol is going to be something writing on the arrow, so I'm going to put something. So you could say that lead is a catalyst, and if lead was the catalyst, I would put lead writing on the arrow. Okay. Wordy would be either, obviously the word catalyst, with the catalyst lead, or in the presence of. So it's like in the presence of greatness. In the presence of. Yields, the symbol is simply the arrow like that. Wordy yields or forms or makes. Oops. Precipitate is the same thing as a solid. See, solid. But a precipitate forms from two Aqueous Solutions. And I think I forgot to differentiate between an aqueous and a liquid something or other in my future point slides here. So I want to do that now. Aqueous means dissolved in. Oops. Water. And liquid means melted. Oops. Or condensed. So, for example, if I throw aqueous NaCl on you, that equals salt water. And if I threw that on you, you would go, man, you're a jerk. If I threw liquid NaCl on you, you would say, ah, because that would have to be like 2,000 degrees Celsius, which would be very, 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 very hot. So very different. So dissolved in water is very different from liquid. So you could drink salt water, although it would taste bad and makes you throw up. If you drank liquid sodium chloride, you would do this again. Hope you enjoyed that. Give the word equation 4. Okay, I shouldn't have done 3 of these. I'm going to wipe one out just because I have to get this done before lunch is over. You need to make sure that everything on here is represented in a word equation. Okay, so all those little symbols, all little yields things. There's more than one way to do this, so I'm going to do a long and a short one here. Solid calcium reacts with. Did you say reacts with would be plus? Gas oxygen. To form solid calcium oxide. I want to warn you, some people, when they see these things, start speaking another language. They would say calcium solid plus oxygen gas, for some reason that's okay, yields calcium oxide solid. In this country of the United States of America, we tend to put our adjectives in our nouns. Other languages don't do that so much. But remember, we are here in the grand old U.S. of A. Stars. God bless America. Speak it right, or you get it wrong. 3. Look how I changed it. Chromium metal. Do you know a metal that's not a solid? No, you don't. Of course you do. There's mercury. But chromium metal, if you say something because it's metal, it's a solid. Chromium metal and oops, this should have a -2 on it. The chromate ion in solution. You're getting all wordy. Yields solid potassium and chromium 3 chromate. How did you get the 3 in chromium 3? Oh, on crisscross. Makes you want to jump, jump. The data will make you jump, jump. Next, keep talking about looking at the MACD and ending with a booyah. There we go. Calcium in the solid state reacts with the oxygen gas to form solid calcium oxide. Calcium in the solid state, Ca(S), reacts with plus oxygen O2 gas to form solid calcium oxide. CaO(S). Solid magnesium, Mg(S), combines with plus fluorine gas, F2. Oh, but look, F2. Ooh, fluorine gas is F2. Remember Knopf, Colbrelli, AT. So it's diatomic, so I need to remember that. To form solid magnesium fluoride, MgF, and there's 2 of them because of the crisscross. Booyah. Gaseous water, H2O little g, decomposes to form. Decomposes, that's going to mean splits apart. We'll talk about that a little bit later. To form hydrogen gas, H2 little g, g, and plus oxygen gas, O2 little g. And notice how I remembered to make my diatomic things diatomic. Methane. We should know methane is CH4 just because we should. We use it a ton. But I put here carbon tetrahydride so you could help yourselves out with that. Carbon is a nonmetal, so I use prefixes. Carbon. Tetrahydride means 4 H's. Reacts with oxygen gas. Oops, methane. Oh, it doesn't tell me the state of matter. Methane is a gas that we use to burn our Bunsen burners and such. It's also in cow flatulence. So some of you are running to dictionary.com to see what flatulence is. So go ahead and hit pause and do that if you need to. Reacts with oxygen gas to form the gaseous product. So both of these will be gases because it's gaseous products. Carbon dioxide, 2 little g, and water, H2O, little g. So when I burn something, I actually get gaseous water. Believe it or not, when you breathe, you are doing a reaction that produces carbon dioxide and in your blue little footprints that everybody does. Your hand on it and put your thumb to be the big toe and all that other stuff. Balancing reactions. This is entirely new topic, so turn the page. Don't leave the bottom part on it. Balancing reactions. A tricycle is made of 2 different parts, a frame and some wheels. Let's assume there are only 2 parts. An equation could be written for this. Frame plus wheel yields tricycle. F is a frame, W is wheel, and T is a tricycle. But we have problems with this because it's not 1 frame and 1 wheel makes 1 tricycle. 1 frame plus 3 wheels, 1 tricycle. Now in a previous equation I actually had, these are called coefficients. The numbers in front of it are called coefficients. And it helps tell us the mole ratio, or the ratio of molecules of these different things. And basically what we want to do is make sure that we have these things balanced properly. And also, just as a nice little point, is the law of conservation of mass says the mass of these 4 things must equal the mass of this one thing. Whoa, that doesn't look like an A. But, and that makes sense if you're thinking about tricycles and wheels. You know, 1 frame and 3 wheels would be the same mass as a tricycle. Basically, the best way to do this is to do a ton of them. So, although these start out fairly easy, what I do is I make little columns, and what I'm trying to do is make sure that I have the same number of H's and the same number of O's on both sides. So, starting out, I count my H's. I have 2 H's because of this subscript. I have 2 O's because of this subscript. And on the right-hand side, I have 2 H's because of this subscript, but I only have 1 O because of this subscript, well, which would be nothing. So what I'm going to do is I'm going to put a 2 here, and what that does is 2 times the 2 by my hydrogen changes this to be 4. And the 2 times my 1 over here makes this 2. So now my oxygens jive, but my hydrogens are messed up again. Sad. But I think I can fix that fairly easily. 2 times 2 is 4. 4 hydrogens on both sides. Check, check. 2 oxygens. Check, check. And we are done. Yay. Next one. Keep on cruising. Whoa. All these letters. So what I'm going to show you here is cheating. I'm highlighting phosphate right here because phosphate's on both sides. And I'm going to highlight hydroxide here because hydroxide's on both sides. Now I've talked about how much I've dreamed of the day when you guys would see phosphate as being PO4 and hydroxide as being OH. And as long as they're on both sides of the reaction, you can treat them as being the same thing. So it's not Na3PO. O. It's Na3 phosphate. So let's go ahead and do this. Na equals 3. PO4 equals 1, because the parentheses here would be 1. K equals 1. Hydroxide equals 1. And on this side, Na equals 1. I like to do the same order as over here because checking it makes it easier. Phosphate equals 1. K equals 3. And OH equals 1. So the first thing I notice is my K's are messed up. So to balance my K's, I'm going to put a 3 over here. And that fixes my K's, but it messes up my hydroxides. The other thing I notice is my sodiums are messed up. So I have 3 sodiums over here, just 1 over here. So if I throw a 3 over here, I get 3 sodiums, but I'll also get 3 hydroxides. Hey, looky there. 3, 3, 1, 1, 3, 3. Woo-hoo-hoo! I'm all done. Okay. Now we get a little bit harder. This is a combustion reaction. We're actually burning something. So when you burn something, this is hexane, you get a little bit, sometimes it gets to be a little bit tougher. So here we go. Carbon, 6, hydrogen, 12, oxygen, whoops, 2, pardon me. Over here, carbon equals 1, hydrogen equals 2, oxygen equals 3. 3? What kind of weirdness are you talking about? I only see 2. Oh, I see now. So starting out on top, I see that I have my carbons messed up. So let's go ahead and try and fix my carbons. So if I put a 6 here, I'll then have 6 carbons, and then I'll have 12 plus 1, 13 oxygens. Then if I want to try and fix my hydrogens, I could put a 6 right here. 6 times 2 is 12. Yay! And then 6 times 1 is 6, plus 12 is 18. Okay. To fix my oxygens, to get 18 oxygens, I could put a 9 right here. 9 times 2 is 18. And 6, 12, 6. Hey, I'm all done. Ooh, look at the big numbers. Wow. I feel pretty smart right now. Let's do another one. Okay, so looking at this again, do you see any polyatomic ions I can cluster? Because this looks pretty long. Yes, I do. NO3 is nitrate. So we'll cluster the nitrates. Rubidium equals 1. Nitrate equals 1. Be equals 1. F equals 2. On this side, rubidium equals 1. Nitrate equals 2. Oh, not matching. Be equals 1. And F equals 1. So I saw my nitrates don't match, so I'll throw a 2 in front of here and get double the rubidium fun, double the nitrate fun. So now my rubidium's messed up on the right hand. So I'll throw a 2 in front of rubidium, 2 rubidii, and 2 fluorines, and I'm done. Woohoo! This is so cool. I wish everything was this easy in chemistry. And here's the same problem we did just a few moments ago. C6H6 plus O2 yields, that's C6H12. Oh, so it's not the same, so our coefficients will be different. So carbon equals 6, hydrogen equals 6, oxygen equals 2. Carbon equals 1, hydrogen equals 2, oxygen equals, I'm not going to fall for your tricky one. Oh, there you go, 3. All right. So carbon's messed up first, so let's try and fix carbon. That gives me 6 carbons, and 12 plus 1 is 13. Hydrogen equals 6. Let's try and throw a 3 here. 3 times 2 is 6. And that gives me 12 plus 3 is 15 oxygens. Ooh, our coefficients at this point in our lives must be whole numbers. So there's not a whole number I can put in front of something that's going to be multiplied by 2 to give me 15. So what I do when I get into a situation like this is I usually look at the biggest thing in there and double it. So C6H6 is a big monstrosity, so I'm going to double this monstrosity, hoping it will fix things later. So my carbon becomes 12. My hydrogen becomes 12. Oxygen is still 2. So in order to get 12 carbons, I now wish I would have used pencil. And I put a 12 in front of here. That's a big number. Yeah, it is. 12 times 2 is 24. Oop. Plus 3 is 27. That doesn't look like it's helping much. My hydrogens need to be 12. 6, still wishing I would have used pencil, because I'm sure you did. So that would give me 12 hydrogens. And 6 plus 12 would, well, 6 plus 24 would be 30. So what would I put in front of oxygen here to get me 30? Ooh, your times and divides and skills are supreme. 12, 12, 30, 12, 12, 30. I'm all done in 20 minutes and 40 seconds and got it done in lunch period. Yay! Hope you enjoyed the test. There are more coming up. Have a good one, and I will see you in class tomorrow.